Hey, I thought I'd just take a look at the X3121 Triang power bogie fitted to the blue Pullman and to the DMU right from the late 50s. This is just a chassis and the bogie does have some challenges. So that's a good chassis and that is not. This is the problem point. You can see on this one how worn where the wheels take the weight of the chassis. The difference is quite noticeable. Second issue, which is not a fault so much as just incompatibility. When we were way back in Series 3 and Triang Super 4 track, the flanges tend to be a lot deeper, but those flanges will not work on Code 100 like System 6, Pico, Flexi Track, etc. The only solution is to change the wheels out, but they're hard to get. Yeah, so this is a bogie that suffers with a worn chassis, and it had deep flange wheels which don't run on my layout. So apart from the more modern filter, what I've done with this is I've put in, it's maybe easier the other way around, a strip of phosphor bronze, 0.2mm thick, 1.5mm wide, and it's simply sandwiched between the magnet bracket and the chassis on the return side, this being the live side. And that has done two things. It has taken the contact from the chassis side wheel to the chassis without relying on it going through the worn bearing. But furthermore, you can now use, with this configuration, nylon axled wheel sets, X336 I believe is the part number, that would have existed on models like the original Class 37 and Class 31. Those wheels were more prevalent in the shallow flange size. You can get deep flange ones, but the shallow ones are still available on eBay. This configuration also tends to reduce the rocking as there's downward pressure on this side. It does mean the bogie lists, so it is not an optimum solution by any means, but it is a means to an end if you want to get a bogie to run that suffers with the deep flanges and the wear. So although the phosphor bronze strip that I've added makes the rocking motion barely noticeable when it's running, you can see there is still some, and when you put maybe an R157 body over that, the shaking is quite noticeable. So as I said, it's not really that great a solution. This is an original unmodified bogie with the original inductor and suppression resistor, oil pads, and the wheels that have got a brass axle with an insulation piece on these ends of the axles to separate these wheels from the rest of the axle. So on this side, conduction comes from this contact spring up through the brown wire to the insulated brush, and on the other side It simply comes from the rail to the wheel to the axle onto the chassis itself, and from the chassis it's passed this piece of copper or brass, it's not copper, it's brass, under the magnet, and then goes around this wire clip that is a double purpose. It's sprung to hold the brushes in place, and in this case it conducts on that side. It's insulated, and this red wire is the continuation of the brown wire after it's gone through the inductor. Really good in its day. We could keep them going forever if we can get parts, but we don't seem to be able to get the parts anymore, so hence my modification. I've concluded for the moment there is really no good fix for worn chassis, so I'm setting that problem aside. The modification I'm going to go through now is principally to improve the connectivity between the wheels and the brushes, and also to allow the use of the nylon axled wheels, which appear to be more available in the lower flange depth form than the original wheels designed for this bogie. This is the insulated plate from the bottom of the bogie, which I have abraded with a file on the chassis side. I then took brass strip, which is 3mm wide, 0.5mm thick, and tinned it, and then superglued it to the chassis side of aforementioned plate. I sprayed the plate with a super glue activator. I can tell you, you get absolutely no adjustment. When they contact, they stick. I then soldered the 1.5mm phosphor bronze strip at roughly right angles onto the brass strip. I then applied a black wire to the chassis side onto the phosphor bronze strip and replaced the brown wire on the live side with a more flexible wire. I've found that I think over the years these wires that Triang used have started to become brittle, and they just tend to snap off the connecting pieces. This shows the nylon axled wheels in place. As it transpires, I had to replace them with better wheels, as these ones had worn gears and the worm tended to jump gears. This is the bogie reassembled with the new contacts on the chassis side. This is the finished article. The inductor is connected in series with the wire coming from the live pickup on the wheels. The capacitor is connected in parallel after the inductor and then to the return side of the power. I haven't replaced the brass strip that ran from underneath the magnet and connected the faraway brush as viewed in this picture to the chassis. You could achieve the same by sleeving the spring clip on the faraway or the return side brush. There is a bit of a benefit in as much as if there's a bit of wear, you can on occasion get one of the wheels making contact with the chassis, and obviously if that's the live wheel then you effectively get a short. It's a small point, but there's no need to have the chassis connected to either of the rails, so it's as well not to, in my view. I find it's good practice to only connect light wires to the tabs that take the power to the brushes, to try to avoid any strain being placed on the brushes which can cause them to run badly on the commutator. As can be seen, it runs pretty well. I'm not sure if it's the benefit or not, but presumably with the nylon wheel sets, the chassis will not get worn at all and are therefore kind of sacrificially protected. But who knows how long the nylon wheel sets with the shallow flanges will be available. Having run the Bogie extensively, I'm happy with its performance, and so I have heat shrunk the wiring to the inductor and secured it down so that there's no risk of shorting. So there it is.